Welcome. Let's get started with a quick introduction to networks and networking, the basic components, a little bit of history of how networking got started. So let's go ahead and we'll advance this slide here. I remind you, just go ahead and pause the video at any time to read in detail slides that you'd like. So first networks were called sneaker nets, and the idea behind that was we didn't have the ability to connect two computers together. So consequently, the way we shared files was to copy them to a floppy disk like the one here and either share the file or move over to another computer that we needed to work on. Prior to that, we had this idea of mainframe computers with dumb terminals. So that was the idea that the computer sat in a big room. It was too noisy to work in there. And so we created another room close by with dumb terminals. And those terminals would use the processing power of that single computer. So all we basically had was a keyboard, a monitor, and towards the end, limited mouse functionality, not really from a GUI or graphical user interface for the most part. So the internet, however, started with this idea from the Defense Advanced Research Projects Agency, DARPA, called ARPANET. And what I've done is I've pulled up a slide for you to read, so I would encourage you to pause this. And this will give you a brief history of what ARPANET was and how it got started. From there, mid-1980s, this is when it really came around to the idea of the PC, the personal computer in the workplace. Here's an example of a IBM PC, one of the first personal computers that was released to market. So late 1980s, businesses commonly networked those PCs so that we could share data. And the way that was done in BryanNet at Bryan College, the first general use of a high-speed network, the throughput was 2.5 megabits per second. So what are you getting now? Well, through Ben Broadband, you can get upwards of 100 megabit per second internet connection. So originally token ring, there's a little graphic here that's playing for you. It shows how it works. Basically, packets would go to computer number 1 and say, are these for you? No. Oh, okay. How about 3? No. Oh, look, they're for 4. Once computer 4 would talk to that computer and then want to respond with some packets, it would complete the ring. So consequently, an inherent issue with token ring was if we somehow broke that ring, we broke our network. So 1990s, the World Wide Web was established as a viable entity on the internet. So the internet is actually the hardware and software infrastructure. So this is the hardware, the routers, the wires, etc., that make up the internet, the way we communicate at the physical level. And the World Wide Web is the service, the software that runs on top of the infrastructure of the internet. So the World Wide Web is how we get out to Gmail, how you get to Facebook, etc. Local area networks came about, and this was, limited to, granted, a local area. Usually limited to one building or several buildings that were nearby. It really depended on the physical layer, what wires, how far we had limited to run those wires or to increase the signal so we could go further with equipment. Sometimes limited to certain rooms in a building, we can create a LAN. Most likely you now have a LAN at your house where you're sharing internet connectivity amongst your DVR, your wireless devices, your laptop, your desktop if you still have one. When LANs came about, the idea of having a server that managed the network. So from a security standpoint, from giving out DHCP addresses, as well as specialized servers such as an email server so that we could have email in our local area network without having to go out to the web if we didn't want to. More on sort of local area networks started with this idea of a peer-to-peer, so there wasn't servers. Best used with 10 or fewer computers, very hard to maintain. And the reason being, what we had to do in a client server environment, we have a server that would manage access and user control on the network, user access, authentication, control. Here in peer-to-peer, if this user right here wanted to share some data with this user right here, what we had to do was create user accounts and access on each computer. So you can see how cumbersome that very quickly came. Also, set up static IP addresses if we didn't have a DHCP server in place. So that gave way, of course, to wide area networks. The largest wide area network that we know about today is the World Wide Web. So can stretch across large geographic areas. Internet, of course, the biggest one. Enterprise networks, so WANs in company offices, buildings. So an example of WAN might be something like Les Schwab, for example, where Les Schwab has locations, throughout the Pacific Northwest. All those locations, technically, all the computers in those locations could technically communicate back with the corporate office, therefore sharing data across all the locations. So here's an example of a wide area network. Notice what we tend to have is a bunch of local area networks, okay, that are connected with communication protocols such as tunneling protocol or point-to-point that basically allow these long stretches of distance between the networks. So metropolitan area networks, not really, thought of as much, but, it's the idea of a single network larger than a LAN, but slightly smaller, small to be considered to a WAN. So metropolitan area networks might be something along the lines of the city of Bend and having multiple locations that they do operations in and connecting all those operations. So, they say 50 kilometers is a maximum. Links college campuses. So we could technically say that Central Oregon Community College is more of a MAN because we're able to connect outlying campuses, Prineville, Madras, etc., into the main campus. So sharing data, getting email, etc., becomes pretty easy. So here's an example of a metropolitan area network, where we have a local area network, and what we do is we use routers and then some sort of line. It could be fiber optic, it could be dedicated, we could be leasing it from a telephone provider or internet provider to connect these buildings throughout a large geographical area. So let's switch a little bit. We'll talk about the basic network topologies, bus star, ring, mesh, point-to-point, point-to-multipoint, and hybrid. Now, realistically today, the majority of networks are going to be hybrid networks, but we've got to understand where we came from before we can progress to where we might go in the future. So I find these to be a little bit out of order, but a bus topology is all computers in the network are connected to a main cable called a backbone. So we'll take a quick look at this. Here's an example of a bus topology. Normally, this is the connection here. We terminate both ends. One might be terminated to a server that communicates with all these. Here's an example of the British naval connectors that were used for these, and a T connector, so that we could then send packets. Hey, is this packet for you? No. For you? No. For you? No. Yes, it is. And then send that packet back. Now, we'll get into the technology, how this works, and how it did this in a later presentation. So star topology, most commonly used, several workstations connected via a central device such as a hub or switch. Today it tends to be a switch. Advantage, if cable of one computer goes bad, it only affects that computer. So it wouldn't affect the whole network like it would in a ring or a bus topology. Disadvantage, centrally connecting devices goes bad, entire network. So if our switch that we're connecting 50 computers to suddenly goes bad, all 50 of those computers could be taken offline. Now, normally what we would do, of course, is provide some redundancy in there if need be, and at least have a backup or enough ports to connect the mission critical computers back online. So that was, by the way, an example of what a star network, so this would be the hub or the switch that all of them connect to. So ring topology, backbone cable is formed into a ring, all connections. That's what I showed you initially down here in the bottom right. That was a ring topology. So all of those computers, Advantage uses token, avoids data collisions. Why? Because everything flows in one direction. So there's nothing that's ever going to collide with each other. However, inherently slow, if I've got to get all the way around that large ring, back to communicate with the computer at the start. So backbone breaks, entire network goes down, network becomes very slow when large amounts of data are being sent. So if a bunch of computers are sending data on our token ring at one time, on our backbone, there's only so much bandwidth that we had, and it can definitely slow down our network. Mesh topology. So here's the idea of redundancy built in. So every computer or building is connected directly to another computer or building, most commonly used in a WAN environment. So the number of connections on that can be calculated by this algorithm here. Advantages, reliability, redundancy, high availability. Disadvantage, number of connections grows quickly because it's so easy to put computers on. However, if you notice, in a mesh network, when we're starting to connect all these buildings together, suddenly if I lose one of my communication channels like this one here, can building, let's call this building 1 and this building 3, can they still communicate if they lose that direct channel? And the fact is, yes, they could communicate through 2 and around, they could communicate through 4 and around, and we don't end up with losing connectivity and gaining redundancy. So point-to-point topology is the idea. Now we see point-to-point primarily in WAN, type topology, and that's where we have that leased line that connects us from one building to another, or further from one office in Bend to another office in Portland, for example. So where we're actually doing a direct point-to-point, we own the cable, we're not leasing it, or other people's data is not going over it. So only one computer is directly connected to one another computer. Now notice that this can be a computer to a computer, this can be a mainframe to a workstation, this can be a workstation with some sort of wireless point-to-point. And normally though in WAN connections, this is going to be a router to a router, so some sort of internet connectivity that's going to directly connect two routers together. So and that would just connect the two routers. Now in the case of the internet, we can't just connect two routers together, so we have a variation of point-to-point called a PointtoMultipoint. And if you notice here, this can be our primary point. It can connect to multiple routers. This could be, any of these could be, and what that does is again creates sort of a mesh between routers. It gives us redundancy, and as we'll learn in future presentations, it also allows us to choose the shortest path that our information can get from point A to point B. So again, if you have need a little bit more time on these slides, just go ahead and pause the video. So here's a point-to-multipoint. We can have a switch that connects to many switches that have computers connected to them. Now if you notice in this case, if this switch goes down, anything connected here would go down. Now if we mesh this and thus connected here and here, then suddenly if this switch goes down, we can at least communicate between nodes on these switches. So same thing here with routers, just giving you an idea of what it might look like. So again, most networks today are some sort of hybrid, a combination, especially as we get into WAN. We'll talk more about the standard today, which is Ethernet, and more about sort of the mesh topology that's created. So, hybrid networks, we can have switches, connecting. Again, you won't find a ring topology all that much anymore. You're going to find a lot of mesh networks using Ethernet, connecting with routers, etc. So physical versus logical, we'll definitely get more into this. This again is just an introduction. So physical topology, the shape of the wires. Logical topology, the shape of the path that the data flows as it moves through the network. So logical data, physical, the actual wires that it's running on. So Here's a star topology using a logical bus. So there's a bus there and the star. Not something really you would see. It's really the idea. Here's logical ring. But today, this of course is going to be a switch, and we'll talk more about how that switch knows to get traffic from this computer to this computer without having to go in a ring topology through all these computers to say, hey, is this your data? So basic network configuration in Windows, the user access control, just some ideas of how we might connect our computer. I'm going to give you a video on how to do this. This is pretty dated with it being security in Vista. Network and sharing applet, of course, easiest way. Right click down on your little computer icon that has your connections. Go to your network and sharing center. Go ahead and open that up, and you'll be able to do these things. Again, I'm going to provide another video for that at a later date. So here's that network and sharing center. Really hasn't changed much. Lets us know, are we connected? Where are we connected to? So, here's Timothy's PC. It's connected to some sort of Linksys device, probably his wireless router, given that this is a wireless network. And then here's his ISP, his internet service provider, that's providing connectivity out to the World Wide Web. So there's a summary for you. Again, you can pause and read through that if you want. That's what I have for you today. Have a great day.